I'm going to go over critical sites, airflow, and first air. So starting with critical sites are defined as any location that comes into direct contact with fluid or powder during the compounding process. These sites must remain sterile and untouched as they may carry microorganisms or foreign matter that can reach the patient. These sites include the injection port, the injection site, the plunger of the syringe, a luer lock of a syringe, all parts of a needle except for the cap, and the ampule, neck, and shoulder. Moving on to airflow, we're going to be talking about your working environment. So you have your horizontal laminar flow hood and you have your vertical flow hood. So the horizontal laminar flow hood is the most commonly used hood as it is used to compound non-hazardous medications. It works by extracting air from the environment through the vent, which is located at the bottom of the hood. The air reaches the HEPA filter, where 99.97% of airborne particles are caught in between the fibers of the filter. From there, the air gets pushed out of the HEPA filter towards the entrance of the hood, where it will blow away particles, debris, and bacteria, which keeps the environment sterile. When it comes to placing things inside of your hood, you want to make sure that your critical sites are in first air. Now, what first air means is that your critical sites are not being blocked by another object and that they are able to receive the airflow coming from this back filter. This back filter is called your HEPA filter. Your HEPA filter filters out the air from your environment, free of bacteria, free of dust, free of pollen, and it pushes anything that's settling onto your critical sites. So your critical sites being your injection port, the neck of your ampule, your injection site on the top of your vial, your plunger, your hub of your needle, and then as well as your entire needle besides the cap. So everything in here is placed in first air. You have your airflow hitting the injection port directly, hitting the neck directly, hitting your injection site directly. What wouldn't be first air would be this. So this is your injection site, this is your critical site. Your critical site is not facing the airflow, therefore the airflow cannot push anything off of your critical site. This is first air for the vial, but not for the ampule. So your vial is getting first air, but not your ampule. This would be incorrect as well, as your injection port is facing away from the HEPA filter. So this is the proper arrangement of it all. For your syringes, this would be first air. Your plunger is not fully extended, therefore it does not have to be in first air until it is extended. Your hub is in first air. Now, if your plunger was extended, this would still count as first air because this is receiving airflow and so is this. This would not count because this is receiving airflow, but your plunger is not. Okay? Same with the needle. So with the needle, if I can get it open, this would be first air because the hub of your needle is facing the filter. This would not be first air. Now we're going to talk about the vertical laminar flow hood, which is used to compound hazardous medications. It has the same purpose as a horizontal flow hood, which is, to make the environment sterile, but it has a different technique. So instead of the vent extracting it from the bottom, it extracts air from the top, and then that gets pushed out from the top rather than the back. There's also something called a sash that's there to prevent inhalation of any hazardous medications, which ultimately protects the pharmacy tech when compounding. So now I move to the vertical flow hood. The position of your critical sites are going to be a lot different from if they were in the horizontal flow hood. Your airflow is coming from the top, so you want to make sure that your airflow is directly hitting the critical sites without anything blocking it. So this is perfectly fine, but if you were to have something blocking it from the back, that would be okay because your air is coming from the top. What wouldn't be okay if I had, let's say my hands covering the top of the vial. Then that wouldn't be okay because the airflow isn't directly hitting the top of the vial, it's hitting my hand. if I had my plunger on my syringe extended, this would be considered unacceptable because the airflow isn't hitting the plunger. But this would be okay. And if somehow my vial turned upside down, that would also not be acceptable.